Good. How about yourself?
Good. All right, you're going to verbalize some stuff?
Yes. I'm just doing some review for the polynomial expressions and equations.
Okay.
So I'll start the first one. It's going to be q squared plus q minus 30.
Minus what?
30.
Okay. Work me through the 3 steps here. Or 4,
Okay.
let's say 4 steps.
Okay.
First
So
step.
we distribute the q to both to parentheses.
Okay.
And then it's going to be a plus and a minus.
Okay.
And then we find the factors of 30 that equal 1.
Not equal 1.
Or subtract 1.
Subtract because of that right there.
Okay.
Okay, so that sign is very important. Not only does it tell you that these 2 signs have to be opposite, but it also tells you the factors of 30 need to subtract to the coefficient number of the middle term. Okay, so our 2 factors would be 6 and 5, right?
Mm-hmm.
Now, which term does the 6 go on, and which term does the 5 go on?
6 goes to the plus and the 5 goes to the minus.
All right, the larger factor always goes with the sign of the middle term.
Okay.
Okay, good.
Awesome.
What else?
Okay, the next one is 5x squared minus 17x minus 12.
5x squared minus what?
17x minus 12.
Okay.
Okay, so there's no greatest common factor.
Yeah.
So,
Right, that's first step.
Yeah.
See if we can simplify it a little bit. We can't.
okay,
So now this is considerably more difficult than the other one.
because of the 5.
Yeah. In other words, as soon as you have something other than x and x, you can't use all of those nice rules. You just kind of have
Okay.
to do it by trial and error. There's only one way to break up the 5x squared, though. That's helpful. How should we break it up?
Just 5x and 5x.
No. Remember, it has to multiply.
1x, my bad.
It has to
It's x.
multiply back to give you that. That's the requirement.
Okay.
So if I had 5x and 5x, that would be 25x squared. Okay.
Okay.
Second step?
It's going to be a minus plus.
Well, the signs have to be opposite. And in this case, because these coefficients are different, then it could be minus plus, and that might be different. In other words, in this case, plus minus is not the same as minus plus. So we kind of have to allow for both situations. It's either plus minus or minus plus.
Okay.
Now, we still need factors of 12. But we can't say anything about them. We can't say that they have to subtract to 17 or add to 17 or anything. We just kind of have to experiment a little bit.
Okay. So, you'll do 3 and 4 then?
Well, okay, so we want to try, we'll just randomly assign the 2 closest ones, like that.
Okay.
Hold on a moment. It's amazing how often that's the answer. That was the answer, okay?
Oh,
3 and 4 was the answer. And when I say it's amazing how often if you take the 2 closest factors and put those 2 numbers here, that's the answer.
Mm-hmm.
But let's assume that I started off with 3 and 4 like that. Okay?
So negative 3 plus 4.
What's that?
-3 plus 4?
Yeah. In other words, let's say that was my first choice. In other words, I just randomly started. I could assign them up here. I could assign them down here. I'm going to point something out, though. Okay, now, is this correct?
No. Oh, yeah, it is.
It's not correct, but it gives you the right number.
What numbers?
It just doesn't give you the right sign. And that's important because that means that is all I have to do is move these numbers up to the opposite sign and I'll have my answer. In other words, if this comes up to the right number, wrong sign, then you know the answer is the 3 there and the 4 there.
Okay.
If, I'm not done with this problem yet, so that would work, okay? Let's say I didn't start with 3 and 4. Let's say I started 6 and 2. Okay? Now, notice that that's plus 6x. This is minus 10x. Together, you get minus 4x. Well, that's not even the right number. It's the right sign, but it's not the right number. So it's certainly not going to do me any good to move the 6 down to here and the 2 down to there, because I know that all that does is changes the sign.
Okay.
So what that tells me is that eliminates one of the needs for me to try that possibility. In other words, I know the 6 and 2 doesn't work like that. If 6 and 2 are the answers, then the 6 has got to go over there and the 2's got to go there. But there certainly is no point in trying the 6 down here and the 2 over there since I already came up with the wrong number. Well, 6 and 2 aren't it, but 3 and 4 are.
Okay. Okay, the next one's negative 2n squared plus 15n minus 7.
Okay. So first.
Okay, so we start out by doing a negative n in both.
Hold on. You could do it that way. In other words, you could break this up into negative n and 2n. But I have found that that makes it particularly more complicated. I think that you always want to start with a positive exponent in the front of your squared term, just for doing these. So how do I get a positive exponent?
Yeah, subtracting a 3. Subtracting out a negative 1, I'm sorry.
Dividing all 3 terms by negative 1. In other words, factoring out a negative 1. I can't just divide all 3 terms by negative 1, but I can do this. So I've turned this quadratic that had a negative coefficient into a quadratic with a positive coefficient. Now this is much easier to factor, at least for me. You can't lose the negative 1. We still need that negative 1 out there. But now we're just factoring this, okay? Break up the n squared terms. So what's the next step?
Okay, it's gonna be 1, or it's gonna be n, right?
No, n and n doesn't multiply.
Okay, 2n, sorry. 2n.
Always check that. Once you've done it, once you've broken it apart, in other words, once you've accomplished step 1, always, always multiply these 2 things back together to make sure you get this. Otherwise, the whole rest of the problem will be messed up. Okay, if you don't start that first step correctly, it messes with things. Now, what are the signs?
Okay, it's gonna be plus and negative.
Hold on. How can we produce a plus?
Oh, 2 negatives.
Correct. Either 2 negatives or 2 positives, right? That's the only way.
Right.
We can't have opposite signs. We have to have the same signs, and they're always the same as the middle term. So it's negative, negative. Now that makes it particularly easy because there's only those factors of 7. So either it's 7 here and 1 there, or it's 1 here and 7 there. Well, this one doesn't produce 15n. So switch them, 1 and 7, and notice that does produce minus 15n as a middle term. Okay? Now, the reason I think this is much easier than doing this one up here is if I start with this and I don't factor out that negative 1, then what I start with is a negative 2n and an n. But now I don't know what my signs are because that sign's negative, so it looks like maybe my signs are negative. You can't really figure out your signs when one of these is negative to begin with. So never, I say never attempt to factor this in this way. Always take out a minus 1. That's all you have to do to turn that positive. You just have to make sure you take out a minus 1 from each term.
Okay.
Okay. What else?
Okay, next one is a squared minus 121.
Okay. What's that?
So would you distribute the a?
No. When you see a problem like this, where you have just the squared term and a number being subtracted from it, it's almost always, and in fact I'm going to go out on a limb here and say 100% of the time, it's the difference of perfect squares.
Okay.
Notice that is a perfect square. That is 11 squared. So that is a perfect square. And we're subtracting them, so we have the difference of perfect squares. So how does this factor? It really makes it much easier to factor difference of perfect squares is if you recognize it, it's pretty easy to factor.
Right. Would it just be a minus 11, a plus 11?
So these problems are the easiest problems of all. Once you have difference of perfect squares, it's pretty easy. Now, sometimes they will give you a problem like this. Now, that's not the difference of perfect squares. This is not a perfect square, and nor is this. But if I factor a 2 out,
Which you can.
you're left with the difference of perfect squares. And so this becomes 2 times a minus 11 times a plus 11. Okay? So whenever you see this, know that either you can take a greatest common factor out and you're going to be left with the difference of perfect squares, or it's the difference of perfect squares to begin with.
Okay.
Now, I don't know if you'll learn it this year, but there's also difference of perfect cubes, and there is the sum of perfect cubes. And you will, at some point, you'll have to memorize those.
Okay.
Okay? But the difference of perfect cubes would be a cubed minus b cubed, or something like x cubed minus 8. That's a perfect cube, that's a perfect cube.
Okay.
So this would factor into x minus 2 times x squared plus 2x plus 4. And there's a formula for factoring the difference of perfect cubes. Like I said, I don't know if you'll get it this year, probably not. But at some point you will get it. All right, what else you got?
Okay, the next one is 9k squared plus 24k plus 16.
You and I didn't go over these already? Because I think I've gone over these with somebody else. I wonder if I must have another student that's in your same curriculum. either,
Like the exact same problems, or?
yeah, no, these exact same numbers. I remember the 5 and the 17, that one. And I remember doing this one also. This is kind of an interesting one.
Yeah.
Is there anything greatest common factor we can take out?
No, there's not.
Okay. So, how are we going to start it?
We have to find a greatest common factor, right?
There isn't one. In other words, it's like a regular quadratic. Start by splitting up this.
So what about 3? No, about it. Yeah.
That works. That may not be the right answer because another possibility is 9k and 1k. Okay. But we're going to use our standard formula for doing this, which is by formula. I mean, we're going to always start with the 2 factors that are closest together. And 3 are closer together than 9 and 1. Okay. What's next?
Okay. Find the symbols, plus and plus.
And finally, now we still can't say factors of 16 that do anything. What we are left with is factors of 16 that we have to just try randomly.
Okay.
Which 2 shall we try for starters?
We do 2 and 8. We can do 4 and 4.
There you go. Does that work?
Let's see. 12 and 12 is 20. Yep, that's
Done.
Now, could you just also do 3k plus 2 squared? Or plus 4 squared?
I'm sorry, what?
Couldn't you just write your final answer as in the parentheses 3k plus 4 squared?
Oh, yes, you could.
Okay.
Yeah, it does factor. I didn't notice that it did factor into the 2 same things, huh? You'd probably, if they said factor it, you'd want to put your answer like this. Don't think you'd want to write it 3k plus 4 quantity squared. They'd probably accept it, but when you're factoring something, they want it separated. And when you do that, you're kind of putting it back together again almost. I mean, you're not multiplying it out, but you know what I'm saying? They would rather see it like this.
Okay.
Is my feeling. I might be wrong. Your teacher might not object to that at all, but I suspect that they might.
Okay.
Okay.
The next one is 4x cubed minus 12x squared plus 3x minus 9.
Okay. Is there any greatest common factors?
Well, no. But don't you, for these ones, once you put the 4x cubed and then the 12x squared together?
Yeah.
And the 3x
Yeah,
and the 9?
let's talk about factoring cubics, because that's what this is. This is not a quadratic, it's a cubic. And it's not easy to factor cubics.
That's a little fun.
There's one situation where you can do it. And that is where the ratio of that number to that number has to be the same as the ratio of that number to that number.
Okay.
And notice that 12 over 4 is the same as 9 over 3. And the signs have to be right also. This is really minus 12 over 4, and this is really minus 9 over 3. So the ratios are exactly correct, which means that we can factor it by what they call grouping. Okay? As all grouping is putting parentheses around stuff. In other words, I'm going to group those 2 terms together, and I'm going to group these 2 terms together.
Okay.
Now, I can factor a greatest common factor out of this entity on the left, what can I take out of that?
A 4x.
4x squared. Leaving what?
Okay, it would be just x, and it'd be minus nothing, minus x, or 3, I bet.
Okay, remember, the moment you factor that, put it back together again to make sure we did it right. As long as you always do that step, it's going to make factoring so much better and easier for you. If you don't do that step, you risk disaster, because if you miss any, obviously if you miss any term, you're going to lose all credit on the problem. So every time I do this, I always mentally check and make sure that when I redistribute this thing, I get what I started with. Okay? What about over here? What can I take out?
Let's see, a positive 3.
Okay, leaving?
X minus 3.
All right. Notice I got an x minus 3 there and an x minus 3 there. I can factor out an x minus 3. In other words, you don't have to only factor out single terms like that. You can factor out terms like this. You're not used to doing it. This might be the first time you've ever done it. But if I factor out the x minus 3, what am I left with?
4x squared plus 3.
Uh-huh. And there's your answer.
Okay.
And that can't be reduced anymore. Sometimes they can be. In other words, this could end up being the difference of perfect squares, in which case you could factor it further. But in this case, it's not. But you see what we did. We factored out that. And we were left with, when you factor something out, you divide both terms by it. So essentially, we divided both terms by x minus 3, leaving behind the 4x squared and the 3.
So if you don't have x minus 3 for both of them, if you get a different number in the other one, is it
incorrect? Cannot do it. That's what I say. These are enormously difficult because they're only easy like this if that ratio is exactly the same. And they can be very, very tricky. I'm going to change one thing on here in the problem. I'm going to make that a plus. I'm going to make this a minus. Okay. Now, I can still solve this by grouping. Why? Because 12 over 4 is the same as minus 9 over minus 3. They're both positive 3. If I change that to a plus 9, I can't do it anymore. I cannot solve this by grouping. Okay? However, even to solve it by grouping requires a bit of magic. It's not really magic, but I guarantee you 99 out of 100 people would make this mistake. What goes inside the parentheses?
The 3x and the minus 9.
No. Notice that if I do that, I now have something different.
Because you have a minus on the outside?
In other words, if I take away my parentheses, I don't have this anymore. I get a plus 9. So in order for me not to change the value of the polynomial, I've got to make that plus 9 right there. Now, notice that it's exactly the same thing as this. And when I now factor out my 4x squared over here, I'm left with x plus 3 minus, factor out the 3, I'm left with x plus 3. These things have to be the same for you to be able to group them. If one of them comes up x plus 3 and the other comes up x minus 3, you can't do anything with it. In other words, I wouldn't be able to get past this step. They have to be the same. So, and in order to get them the same, well, they are the same, but only because I had to play with the sign on the 9. But this is definitely the most common mistake people make. And now notice what happens. Not only have I changed the function, but now I end up with 4x squared times x plus 3 over there. Factor out the 3, and I got x minus 3 over here. I can't do anything. So if you go to group and you find yourself looking at this situation, in all likelihood, you have made a mistake. You've made the mistake that we started to make. So go back to that step and see if you can change the sign on that. And that makes it correct. Okay? They're not going to give you a grouping problem that causes these two binomial terms to be different. Every grouping problem they give you, these things are going to be identical, these two linear binomial terms. So if you find the sign is wrong, you've made that mistake. Okay? All right.
Okay, the next one is p cubed minus 49p.
P cubed minus what?
49p.
Can't quite understand that number.
49.
49, okay.
P. Sorry.
That's all right. Okay. Is there a greatest common factor?
Yeah, p.
Okay, what's left?
It'll be p squared, and then the minus 49.
What's that called?
That is that's a difference of two squares.
Difference of perfect squares. In other words, these have to be perfect square numbers. If I make that 48, that's not a perfect square anymore.
Okay.
So it's difference of perfect squares, and how does that factor?
It's going to be p and p, and then it's going to be a minus and plus, and then let's see here, 49 squared, right?
No, the square root of 49 is what you want. That's 7.
7.
Okay. But let's back up a step. I notice you went through that kind of using the system we use for factoring quadratics. Don't really need to do that. What you want to memorize is this. A squared minus b squared always factors into a minus b times a plus b. Okay? So, if I give you 4x squared minus 16, and let's make it a 25, what's a?
A would be 4.
Would be the square root of that. That is a perfect square, so a has to be the square root of it. 2x. What's b?
5.
Okay. So this would factor into 2x minus 5 times 2x plus 5. Notice we really don't do it in a 3-step process. Once you recognize difference of perfect squares, you do it in 1 step. Okay? And the one that's hardest to see for people is that one right there, because people don't think of 1 as being a perfect square, but it is. So how does that factor?
The x minus and x plus.
Do it all in 1 step.
Okay. X minus 1, x plus 1.
Right, because see, these numbers are always the same. So you don't need to separate it into 3 separate steps where you have opposite signs. You just know that whenever you see the difference of perfect squares, it's a minus b times a plus b.
Okay.
All right.
Okay, the next one is, in the first set of parentheses, k minus 8. And then the second set, it's k plus 2. And then the third set, it's k minus 7 equals 0.
If I multiply three things together and they equal 0, what has to be true?
One of those is equal 0.
Okay, and we don't know which one, so we're going to let all three of them equal 0 and come up with a solution. Three solutions.
Okay.
So what's my first solution?
X plus 8. Or, sorry, K equals 8.
My second solution?
K equals negative 2.
And my third solution?
K equals 7.
Okay. Now I'm going to check all three of those solutions to make sure they work. Does 8 work?
Yes.
Does negative 2 work?
Yes.
And does 7 work?
Yes.
All three of them are valid. We started with a cubic. We expect 3 solutions. When you start with a quadratic, you expect 2 solutions. Okay? So if you're starting with cubics and only coming up with 2 solutions, most likely you're doing something wrong. You know, it's not impossible for these to be the same. In other words, if this was a k minus 8, then we only have 2 solutions, which is correct, but this is said to be a solution of 2 multiplicity. This has a multiplicity of 1, this has a multiplicity of 2, because there's 2 separate solutions, they just happen to be the same.
Okay.
Okay? Alright.
Okay, the next one is m squared plus 81 equals 18m. Excuse me.
Okay, this is a quadratic that has both the squared term, the term that's raised to the 1 power, and a number. How do we solve these?
By subtracting the 18m to
By
the
getting
side.
0 on one side. That's the way to memorize it. Is whenever you have a typical quadratic, you want 0 on one side. And I do that by subtracting 18m from both sides, just like you said.
Okay.
I'm going to put it in the middle because that's where we're used to seeing it. And that now leaves 0 over there. Well,
Okay.
to solve this, we want to factor this. This factor is pretty easy.
Okay, so it'll be m, and then m, and then it'll be plus or minus, right?
Uh-huh.
Okay.
Now you can use the rules. Notice that because this is 1m and this is 1m, we can now say, okay, I'm looking for factors of 81 that do what?
Subtract to get, or sorry, add.
Add because of that.
To get.
In other words, this sign not only tells you what your signs are, but it also tells you what your method is. So I need factors of 81 that add to the number 18.
Okay, so we can start with 181, right?
We could start at what?
81 and 1.
Okay.
And then, let's see, I don't think 81 is divided by, is divisible by 2. So, divisible by 3.
It is divisible by 3. How do we know?
Because
8 and 1 add up to 9, and 9 is divisible by 3.
That's right.
Okay? However, when the digits add up to 9, what else does it mean? It's divisible by 9.
1.
Always, no matter what. If I write a number like that, I know that's divisible by 9 because I got 1 plus 8.
It would have to be 9 and 9, right?
Uh-huh. And there are a lot of other factors. There are 3 and 27. But remember, we're looking for factors that add up to 18.
Okay. So, okay.
9 and 9.
So then would you, m equals positive 9?
No, m minus 9 times m minus 9 gives you this.
Oh, okay. But don't we have to factor
yes,
them?
I'm sorry, yeah. So,
Oh, okay.
yeah, no, I didn't hear you quite, I think. So m equals 9, only got one solution, but it's got multiplicity of 2 on it.
So you have to say m equals 9 again?
Yeah, and that's all you need to say. You don't need a
Okay.
multiplicity of 2. You need to say m equal 9. The only reason I mention it is because I've been telling you that quadratics you get 2 solutions, cubics you get 3. Well, here's a quadratic where we only got 1 solution, and that's okay. It's just that we got 2 solutions. It's just they're the same thing.
Okay.
Okay? All right.
Okay, so the next one is 3y to the power 4 plus 27y cubed plus 60y squared equals 0.
Like that?
Yep.
Just exactly like that?
Yep.
Okay.
Oh, sorry, 3y to the power 4.
Ah, okay.
Yep.
Is there a greatest common factor?
Yes.
What is it?
3.
More?
Or 1.
No? 3, but 3y squared. Notice that if we don't get this thing down to a cubic or a quadratic, we're not going to be able to solve it. So the moment we see a quartic, you know that you're going to have to factor out. In other words, this is only going to be solvable if I can actually take out a 3y squared. What's that leave?
It's just going to be y squared. And then it's going to be plus 9.
Plus 9y.
9y. And then 3 divided by 60. Would that be 20?
Okay. Now we have a simple quadratic.
Okay.
And that's the way they won't give them to you unless that's the case.
Okay.
Mainly because you're not going to believe how hard it is to factor cubics and quartics if they're not groupable. And quartics are never groupable, but cubics occasionally are. But you can see that for it to be groupable, it has to be very, very unique. Most cubics you'd come across in real life are never going to be groupable. So when you see a problem like this, say to yourself, well, I know that I've got to get this down to a quadratic. Is there any way to do it? And yes, if I can factor out the y squared, I'm left with a quadratic.
Okay.
Quadratic factors how?
Let's see. It's going to be plus and plus. And it's going to be 4 and 5? Yeah.
What are my solutions?
Okay. Y equals 0.
Good.
Y equals -4. And y equals -5.
Right. And again, we started with a quartic, so we expected 4 solutions. We only found 3, but y equals 0 actually comes from 2 places. In other words, that's 3y times y. I'm really multiplying 4 things together. So any of the 4 could be 0, so the y equals 0 has a multiplicity of 2 also.
Okay.
Okay, good.
Okay, next one is, in parentheses, first set of parentheses, x plus 10. And then the second one is x squared minus 25 equals 0.
Times x squared minus 25 equals 0?
Yep.
Okay.
Okay, so...
What can I do with this? I certainly don't want to multiply these together, right? Because the whole point of factoring is to separate it, because then we can solve it if we can get it as a product of a bunch of stuff.
You can simplify the second one,
Yes,
right?
good.
No, you can't.
To what?
Okay. Be x and 5, x and 5.
It's what again?
I'm sorry, x minus 5, I'm sorry.
X minus 5 times x plus 5.
Okay.
Okay? And now what are my solutions?
Okay, let's see, it's going to be, oh sorry, yeah, x equals -10, x equals 5, and x equals -5.
Right. And again, all of those work. If I were to plug each of those back into the original, I get 0.
Okay.
Okay? Now, Let me just show you one other situation here.
Okay.
Solve this for me. In other words, if I had that x squared minus 25 equals 0, I know you can solve it because you can factor this into x minus 5 times x plus 5. But let's say we had the same thing okay? That's the same thing. That's x squared minus 25 equals 0.
Okay.
But there's another way to solve this. And that's by taking the square root of both sides.
Okay.
So what would you get if you took the square root of both sides?
X equals 5.
Plus or minus 5.
Oh, plus, my bad. Or plus or minus.
Plus or minus.
Oh,
and notice, that's the two solutions we're supposed to get, right?
Right.
X plus 5 and x minus 5. We just did it. But if you do it the shortcut way, like this, it's really, really easy to make the mistake and leave off that plus or minus and come up with x equal 5, and you've missed one answer.
Okay.
So just make sure that what I try to teach everybody is that if you are ever solving an equation by taking the square root of both sides, then you need to start with plus or minus. In other words, let me give you a little tougher one. If I've got this,
okay. So, first of all, you would take x minus 1 and x minus 1.
okay, so
And then it would be...
if you take the square root of both sides, you'll get the left side down to x minus 1.
Right.
In other words, whenever something's being squared, if I take the square root of it, well, my answer is that. So that's why we can solve these by taking the square root of both sides. So when I take the square root of the left side, I got x minus 1. What do I get when I take the square root of the right side?
You get an uneven number.
Plus or minus that uneven number.
Okay.
That irrational number, which we leave this way. We're not going to change that to a decimal. We're going to leave it as square root of 7. That's the most accurate way to write that number. What I was trying to get at was don't forget the plus or minus. Okay? And now I can add 1 to both sides, so x equals 1 plus or minus the square root of 7. So there's my two answers. X equal 1 plus the square root of 7, x equal 1 minus the square root of 7. So this technique of taking the square root of both sides is a useful one. For problems like this, it's really useful. Much easier to take the square root of both sides than it is to distribute that out, bring the 7 over, leave 0 on one side, and then try to factor it. Much, much easier to take the square root of both sides here. But do not forget the plus minus. I wish there was a song. You know, they teach a song to memorize the quadratic formula. I don't know if they taught you or not, but most kids in schools, it's like the song to learn your ABCs. A, B, C, D. Sometimes I can't remember my ABCs unless I sing the song. Serious. I mean, same thing with the quadratic formula. I wish I had something to make people put that plus or minus in front. The only thing I can do is just keep reminding you.
Right.
All right. What else you got?
Okay, this is p cubed minus p squared, or p squared, sorry.
First one was just p squared?
Yeah. No, first one's p cubed minus 6p squared minus 4p plus 24 equals 0.
Okay. Is there a greatest common factor?
Yes, there is.
What?
It would be p.
Yeah. I can't divide 24 by p.
Oh, no, it's not. We have to group it, right?
Yeah, in other words, we're looking at a cubic, and the only way we know how to solve a cubic is if it groups. Now, does this group? Well, we have to
Yes.
compare minus 6 to 1, which is this coefficient, compared to 24 over minus 4. Are those the same?
Yeah, I think so.
There, it groups. Now, here's the tricky part. Because of this minus sign right there, you got to make sure when you group it, you don't change it.
Okay.
So group it for me.
Okay, so it's going to be p squared.
Well, first of all, let's group it
Okay.
before we factor anything. What's the rest?
Okay. Is a minus on the outside, and then 4p plus 24.
No. Remember when that minus is on the outside, you've got to change the sign of the number.
Okay, so it's being plus.
And notice now I haven't changed anything. If I take away my parentheses, I end up with this. And that's what you want to make sure you do.
Okay.
Now start factoring the greatest common factor out of each sets of parentheses. What can I take out of this?
P squared.
Leaving
P minus 6.
Okay, over here.
We can factor out a 4.
Okay. And always know when you're doing this that this is going to be the same as this. Otherwise, you're not getting this problem.
Okay.
So it's a little helpful to know that it speeds up the math a little bit. This better be p minus 6. Otherwise, we've made a mistake.
Okay.
I mean, not that it would have to be. If this was a 23, obviously it wouldn't be p minus 6, but we wouldn't be able to solve it either. In other words, if it's groupable, then these two binomial terms are going to be the same. Exactly the same. Now, what's the next step?
Okay, we are going to take p minus 6 times p squared minus 4. Equals 0.
Okay.
Okay. So now we are going to, let's see, oh, we can,
Good. Saw it.
we can divide, yeah.
Fill this in.
Okay. So it's going to be, p in the minus 2, and then p plus 2.
So now my solutions are,
Okay, it's going to be plus 6, plus 2, minus 2.
okay. Always look for that difference of perfect squares. Why? Because you're going to have to do it about 100 times over the next 2 years.
Okay.
If you were to take the ACT test or an SAT test tomorrow, you'd find at least 6 problems in there that needed you to be able to recognize difference of perfect squares and be able to factor. That's how common it is. They really throw it heavily at you.
Okay.
As opposed to these cubics, believe it or not, you would not have to know how to do this problem on the ACT test.
Okay.
They don't give you grouping. They don't give you cubics to factor. That's above the level. So you're getting stuff right here that's harder than any problem you'd get on those tests.
Okay.
Okay, what else you got?
Okay, this one is 3t squared plus 16t minus 12.
Okay, no greatest common factors?
Nope.
Well, let's see if it factors. Get me started.
Okay, it would be 3t, and then times t. Okay, so then it would be Okay, yeah, sorry. Be plus minus plus minus, or yeah, plus minus.
We know the signs are opposite. But the thing is that that is not the same
As minus
as
plus.
minus plus, because notice that one of these things multiplies 3t and the other one multiplies just t. So when I write plus minus, and it can be either way, I do it like this. Okay? And I know it's either the top row or the bottom row. Okay? Now, factors of 12.
2, 6, and 2.
That's all of them.
Okay, and none of them. Oh, yes, my bad. We want to do the 3 and the 4 first.
Okay,
right?
let's try that. What's that produce in the middle?
The middle's going to be 3t.
When I say the middle, I mean what middle term would that produce?
Oh, my bad. Let's see. It would be 12 plus 3 is 15.
Well, it would actually be plus 3
Oh, and then
minus 12. So that's
So
minus
yeah.
9.
-9.
So that
Okay.
doesn't work. Not only does that not work, I know that if I bring the 3 down here and the 4 down there, that won't work either. It's going to give me the same number, just different sign. Okay? So the next thing to do would be 4 here and 3 there. But as all I'm doing is I'm not getting to 16 at all with this 4 and 3. No combination of 4 and 3 gets me to 16. What now?
Try the 16 too.
Okay. And I know that the 6 got to be with the plus, right? Because I got to get the plus 16.
Right.
So the 2 would be with the minus. Does that work? In other words, it's not 100% trial and error. After you try a couple of factors, you realize that you need a big number multiplying a big number.
Right.
Does this work?
It does.
Let's go up here and erase that plus and that minus, and we got our answer. Now what's the solution?
It's gonna be t equals 2 and t equals -6.
Okay, remember to solve it, set this whole thing equal to 0 and solve it.
Oh, okay.
Because remember the theorem in algebra says if I have two things multiplied together, well, I got that multiplied by that, they're equal to 0, set both of them equal to 0. So I'm going to set 3t minus 2 equal to 0. Now solve that.
It's gonna, okay, you're gonna divide each by 3?
Well, first of all, I'm going to add 2.
Oh, okay.
Right? And then, so t is going to be 2/3.
Okay.
So the opposite sign isn't always the answer.
Okay.
If you have a coefficient in front other than 1, then it's never going to be the answer. It's going to always be a fraction like this. And then the other answer?
It's going to be -6.
Yeah, it's always the negative of this number if this is a 1 in front of it. Okay? All right.
Okay, this one is in parentheses, b plus 13 squared equals 0. So would you, okay, so it would be, this is pretty easy.
It is. Yeah.
Would you could just jump to the thing and just do b equals -13?
Yeah. In other words, it's hard to do this one by taking the square root of both sides, but if I just write it like this instead of the normal way, now set that equal to 0, I get -13 as an answer. Set that equal to 0, I get -13 as an answer. I only have one solution.
Okay. Awesome. Okay. This one is 2y times, with parentheses, y minus 9, and the second set of parentheses is y plus 4 is equal to 0.
Like this?
Yep.
Okay. What are my
Okay,
three
so
solutions?
y equals 0.
That's good. Most people will miss that one, believe it or not.
Really?
Yeah, if I give this problem to most of my students, they'll say y equal 9 or y equal minus 4. They forget that this can be 0 also, if it's just a variable sticking out there. So it's good that you're picking that up. And then the other two?
Y equals positive 9, and y equals negative 4.
All right. Cool.
Okay. This one says graph the inequality in a coordinate plane.
Okay.
And it gives you p squared plus 2p minus 35.
Equals 0? Or
No. No.
just graph that?
Yep.
When you're graphing a quadratic, it's going to look like it's a parabola, okay? It's either going to look like something like that or something like that.
Okay.
Always. Every quadratic. If this is a positive first term, then it's going to open up. So I'm looking at something that looks like this.
Positive sign.
Well, it's opens up is the way I term
Okay.
this. It's a parabola that opens up as opposed to a parabola that opens down.
Okay.
Now, there's multiple ways to graph this. Unfortunate that this is the last problem and we just have 3 minutes because there's quite a few, there's quite an explanation as to how we do this. One way to look at it is by factoring it. And that gives me p plus 7 times p minus 5. Well, when I have a quadratic in that mode, that's telling me where my zeros are. My zeros are minus 7 and plus 5, right?
Right.
So instantly, that tells me that my function has to go through minus 7 and plus 5,
Minus 5.
which means I know it opens up, so I know that that parabola looks like that. But
Wouldn't it be minus 5 and plus 7?
no, in other words, if this were all equal to 0,
Uh-huh. Oh, that's right. Okay, because you would basically switch the
right,
signs.
in other words, to find the zeros, it's the opposite sign. Okay.
Okay.
The problem is that parabolas are not defined by 2 points. You cannot graph a parabola with 2 points. You can graph a parabola with 3 points. And the most important point that they always want is the vertex. The vertex being this bottom point right there, the low. So I have 2 very important points graphed, but I don't have that vertex graphed. Well, there's one way, there's a couple of ways of figuring out the vertex. First of all, I need to ask you what they've taught you. Have they taught you minus b over 2a?
Not yet, no.
The other way to graph a parabola is to put it into vertex mode.
Uh-huh.
But to convert this to vertex mode involves completing the square. Have they taught you completing the square?
Not yet.
Okay. I'm not sure how they want you to graph this then. But
Maybe just like a general line, like line of best fit, I guess.
well, No, really, the only way to graph are these two methods that I've talked about. You do know, well, hold on a second. We do know where the vertex is. If I know it goes through that x-intercept and that x-intercept, the vertex has to be halfway in between those numbers. So the vertex is at -1. So right here is the bottom of that parabola. If I draw it a little bit better, if that's my vertex, now I've graphed 3 points. That's -1, and to figure out what the y value would be, I plug it in and solve. It looks like -34. Let's see, we would have 1 -2, that's -1, -36 is where that point is.
Okay.
Now I've graphed it. In other words, I have 3 points. I have the vertex, the most important point. I have the two x-intercepts, the next two most important points. But that's it. Graphing these are relatively difficult. I mean, this one's simple, but only because it factored nicely. And I'm sure that this is the way they want you to do this one. Just factoring it like this, so you get these 2 points, and then the vertex is halfway in between them.
So, Mr. Howard, that at the beginning of the equation you said equals 0.
Uh-huh.
That wasn't in the original equation. You add that after, or?
No, what you were really given was y equals this.
Okay.
There's the polynomial. But in order to graph that function, it's helpful to know where the zeros are. And the x-intercepts, or the zeros, that means that's where y equals 0. So if I'm going to graph this polynomial, I'm going to set it equal to 0, because then I can factor it into these two factors, and now that tells me where my x-intercepts are. So that's why I did it that way. But this is what you were given. Y equals that. They say graph that function. Because y isn't always 0. Y is going to be whatever y is. But like I said, we'll probably spend our next tutoring session putting these things into vertex mode, or finding the vertex based on -b/2a. Okay? They haven't taught you either of those yet, but it's coming. And that's what we'll talk about next session. Okay?
Awesome.
All right, Connor. Have a good one. I'll talk to you next time.
Awesome. Thank you so much.
Bye-bye.